Hello students, welcome to Engineers Academy. Do subscribe my channel if you haven't done it yet. Now we are going to solve this problem from Vector Mechanics by Beer and Johnston, and the problem says that the cable stays AB and AD help support pole AC, knowing that the tension is 120 pound in AB and 40 pound in AD. So the tension in this cable is 120 pound and the tension in this cable is 40 pound. And it is said that determine graphically the magnitude and direction of the resultant of the forces exerted by the stays at A using the parallelogram law and the triangle rule. So we are given the distance between point A and C, that is 10 feet, and the distance between the C and D and the distance between B and C. So from this we can find our angles. So first of all, let's say that this is my angle alpha and this is my angle beta. So the cable AB is making angle alpha with the horizontal and cable AD is making angle beta. So from these dimensions we can find alpha and beta. So if we consider this right angle triangle like this, so we can apply tan alpha, and tan alpha will be equal to this perpendicular divided by the base. So for this alpha, this is the perpendicular and this is the base. So the perpendicular is 10 feet and the base is 8 feet. This is 8. So we can write that the tan alpha is the perpendicular. So the perpendicular is this, which is 10 feet, and the base is this, which is 8 feet. So tan alpha is 10 divided by 8, or we can say that alpha equals to tan inverse, and that is 10 divided by 8. So this is tan inverse 10 divided by 8, and this gives me 51.3. So alpha is approximately equal to 51.3 degrees. Similarly, we can find this beta angle. So using this right angle triangle, we can apply tan beta, and for tan beta, this is the perpendicular and this is the base. So the base is 6. So tan beta is 10 feet divided by 6 feet. This is equal to beta equals to tan inverse 10 divided by 6. So tan inverse 10 divided by 6, this gives me 59.03. So beta is approximately equal to 59 degrees. So now we have to find the resultant by using the parallelogram law, and we have to do it using the graphical method. So we need to select a scale. So first of all, we have to select a scale, and we can say that let's say that 40 pounds is equal to 1 centimeter, or we can say that 1 centimeter length represents a force of 40 pounds. So now we are given that the tension in AB is 120. So we can say that FAB is equal to 120 pounds, and since 40 pound is equal to 1 centimeter, so 120 divided by 40, this will give us 3, so that is equal to 3 centimeters. So 40 pounds is equal to 3 centimeters. So 3 centimeter line will represent force AB. And similarly, the tension in AD cable is 40 pounds. This is 40 pounds. So FAD is 40 pounds, and we have assumed that 40 pounds will represent 1 centimeter will represent 40 pounds. So 40 pounds is equal to 1 centimeter. Since my ruler gives me the angle only with the positive x-axis, so we have to find the angle alpha and beta with the positive x-axis. So if I extend this rope here, so if this angle is alpha, then this angle is alpha, and similarly if I extend this AD, so this angle, we need to have this angle. So if this angle is beta, then this is beta. So this angle will be 180. This whole angle is 180. So 180 minus beta will give me this angle. So let me write that. Find that 180 minus beta. Beta is 59. This is 121. So this is 121 degrees. 121 degrees. So now if I cut these ropes, let me cut these ropes. So we will have FAD, this will be the direction of FAB, and this will be the direction of FAD. So FAD, this line, the line of action of FAD, it is making beta angle with the positive x-axis in the clockwise direction, and in the counterclockwise direction it is making 121 degrees. And similarly this FAB is making this alpha angle with the negative x-axis, and with the positive x-axis it is making that same angle alpha. So now we have to draw these forces according to our scale. So FAB is 3 centimeters, and FAB is making angle alpha with the positive x-axis, which is 51.3. But since this ruler gives us angle up to 2 significant figures, that is, we can measure only until 51. So we have to draw that FAB to an angle of 51 degrees. So this is my 51. And then we have to draw a line of 3 centimeters, since 120 pounds is represented by 3 centimeter line. So this is 3 centimeter line. So this is our FAB. This is FAB. It is equal to 3 centimeter, and it represents 120 pounds. Similarly, FAD is going to make this 121 degrees. This is 59 degrees. This beta is 59. This is 59, and with the positive x-axis it is making 121 degrees. So I have to orient this ruler at an angle of 121 degrees. This is 121, and we have to draw a line of 1 centimeter. So this is my 1 centimeter line. This is 1 centimeter, and this 1 centimeter line represents FAD. Now, since we want to find using the parallelogram law, so we need to consider this FAB and FAD is the two opposite parallel sides of a parallelogram. So I need to copy this FAD, and I need to put this FAD equal to 1 centimeter on the head of FAB vector. And similarly, I need to copy this, and I need to put it on the head of FAD. Let's put it here. So now this is again, we can say that this is FAB and this is FAD. So this is FAB, this is FAB, this is FAD, and this is FAD. So they make a parallelogram, and these two are FAB. The opposite sides represent these two forces. Now the resultant will be the diagonal. So this will be our resultant from this point A to this point. So the diagonal of a parallelogram always represents the resultant, and this is my resultant, this black arrow, and the length of this resultant will give us the magnitude of the resultant. This is 3.4 centimeters. The resultant length is approximately, we can say that this is 3.4 centimeter, and 1 centimeter represents 40 pounds. So 3.4 centimeter represents 3.4 multiplied by 40. This gives me 136 pounds. So the resultant is equal to 136 pounds, and the resultant is making 66 degrees with the positive x-axis, since our ruler gives the angle with the positive x-axis always. So if we extend this resultant, so it is going to make this angle, and this angle is 66 degrees. So let's say that this is angle theta, let's say, and this theta, by using the protractor, this gives me 66 degrees. Or we can say that if this is theta, this is 66 degrees, then this angle is 66 degrees as well. So we can say that the resultant magnitude is 136 pounds, and it is making 66 degrees with the positive axis. Or we can say that it is making 66 degrees with the positive axis in the counterclockwise direction. Or similarly, we can say that it is making 66 degrees with the negative axis in the counterclockwise direction. So, and in the question, we are also required to find the resultant magnitude using the triangle rule. So, the triangle rule is, we can say that the half of the parallelogram law is the triangle rule, or we can say that if we add the forces by head to tail rule, and this FAB plus FAD by head to tail rule, they must make a closed triangle like this. So the half of a parallelogram law always represents the triangle rule. So using the triangle rule, we will have that same resultant. So we need to repeat the method. We only need to draw a triangle. There is no need to draw a parallelogram. We need to draw a triangle, and by measuring the length of the resultant, that will always give us the magnitude using the same method that we have used for the parallelogram law. Now we can find the resultant magnitude by using trigonometry. If we consider the same free body diagram, and we know that FAB is making alpha, which is equal to 51.3, and this FAD is making beta angle, this is beta, which is 59 degrees. So now if I draw a horizontal line here, so if this angle is alpha, this is 51.3, then this angle is 51.3, and similarly this FAD is parallel to this FAD, and if we draw a horizontal line here, then this angle is that 59 degrees. So let me draw those forces again. This is FAB, this is FAB, and this is FAD, and the resultant is from this point to this point. This is my resultant, and this FAB is making 51.3 degrees here, and that FAD is making 59 degrees. So similarly, if we draw a horizontal line here, then this angle and this angle, they are same, since these two angles are alternate angles. So we can say that this is 51.3 degrees as well. And similarly, this FAD is making beta angle 59 degrees with the horizontal. So this angle is 59. So this angle is 59. So the angle between FAB and FAD is the sum of both of these angles. So if we join FAB and FAD by head to tail rule, the angle between FAD and FAB is the sum of this. So we can say that the included angle is 51.3 plus 59. This is 110.3. So this whole angle, this angle is 110.3 degrees. So now we can find the resultant magnitude by using the law of cosines. Since we know the magnitude of FAB, we know the magnitude of FAD, and we know the included angle between both of them. So if this is the case, we can always use the law of cosines, and we can find the solution by using trigonometry. So using the law of cosines, we can say that R square is equal to FAB square plus FAD square minus 2 FAB multiply by FAD magnitude cos of the included angle, and let's say that the included angle between both of them is, let's say, gamma, so cos of gamma. And if we take the square root on both sides of the equation, we will have the resultant magnitude. So now the resultant magnitude is this. Now let's put the values. The resultant is equal to FAB magnitude is 120 pounds, that is 120 square, plus FAD is 40 pounds minus 2 into 120 into 40, and cos of that gamma angle, which is 110.3 degrees. So 120 square plus 40 square minus 2 into 120 into 40 into cos of 110.3, and this gives us the resultant magnitude equals to 139. So the resultant magnitude is 139 pounds approximately, which is close to the answer which we got from using the graphical method. So the difference is due to that limitation of our ruler. Since using our ruler we can only measure the angle up to two significant figures. We cannot measure the angle after the decimal place. We cannot measure the angle up to 51.3 degrees. So this is how we get the difference in the answer. So by graphical method we get 136 pounds, and using the trigonometry we found the answer that resultant is equal to 139 pounds. So this is the more accurate one. And now we have to find the angle of the resultant with the positive x-axis is using the trigonometry. So now we know that with the negative x-axis, this is, let's say, the angle of the resultant, and let's say that this is that angle theta which we want to find. This is angle theta, and let's say that this is angle zeta, let's say, and we want to find this angle using the trigonometry. So now we know the FAD magnitude, we know FAB magnitude, we know the resultant magnitude. So we can use law of sines. So if I use law of sines, we want to find that angle zeta. So we can say that sine of zeta divided by the magnitude of the opposite side. So the FAD is the side opposite to this angle zeta, and FAD magnitude we know is 40 pounds. So sine of zeta divided by 40, this will be equal to sine of this included angle, which is 110.3, divided by the magnitude of the opposite side. So this is the opposite side, which is the resultant, which is 139 pounds. This is divided by 139. So now from this we can say that sine of zeta, by cross multiplication like this, we can say that sine of zeta is 40 into sine of 110.3 divided by 139. And if we want to find zeta, we need to take sine inverse on both sides of the equation. So this is sine inverse 40 sine of 110.3 divided by 139. This gives me zeta equals to 15.65. Let's say that this is 15.7 approximately. Let's say this is 15.7 degrees. Now this is zeta. We have determined this zeta angle, which is 15.7. So now this theta will be equal to this 51.3 plus zeta. So theta is 51.3 plus 15.7. 15.7 plus 51.3, this gives me 67. So theta is equal to 67, and which is close to that value which we got from the graphical method using the parallelogram law. So the resultant is making 67 degrees with the negative x-axis in this direction, and that angle is equal to 67 degree, and the magnitude of the resultant is 139 pounds using the trigonometry, and by graphical method the resultant magnitude is 136 pounds.